train problem. Review. A toy train consists of a 3-kilogram engine, and 2 1-kilogram cars. Was it supposed to snow today? These seem like blizzard conditions, don't they? Oh, I'm recording. I better not. What, that interaction? Yeah, well, it has to do with something. But 1-kilogram cars. The tension between the engine and the first car is 40 newtons. That's quite a tension for a toy train. Find the other tensions. The acceleration of the train. And the force with which the engine is pulling forward. Okay? What was the first step with these? Okay, we'll draw the trains and then we'll add the free body diagrams, right? What is it? It's a engine and 2 cars. Okay? Let's see. Let's start with an FBD down here. What forces do we have on the last car? We'll call that one FT1. We got F perpendicular and FG. Well, the friction part we'll just ignore. There's only a little bit of it on those wheels where they hit the track. Try to make them really friction-free. How about on the middle car? What's the force going backwards? So if this car here has a tension force pulling it that way, the equal and opposite is pulling back on the other car. So it has FT1 like that. And then it's got a bigger FT2. See? It also has an F perpendicular and an FG like that. And then the final engine, on the engine, you also have FT2. That's backwards, back on it. But you have the engine force, F perpendicular, and FG. Make sense? Now what force, we're given the masses of these objects. First, 1 kilogram, 1 kilogram, 3 kilograms. We're also given a force, the tension between the engine and the first car. What is that? It's 40 newtons, and which one is it on our diagram here? FT2, right? So we're going to have to use a free body diagram with that to start, right? So let's start at this side over here, the blue one, I guess. The sum of the forces for the engine is mass times acceleration. What's the winner and what's the loser? Fe is the winner minus FT2 equals MA. We don't know what Fe is, but we know what Fe2 is, don't we? It's minus 40 newtons, or it's 40 newtons. And then the mass of the engine is 3 kilograms times A. We don't know what A is yet either. Okay, so let's go over to this diagram here, this one. Again, the sum of the forces is mass times acceleration for this middle car. What's the winner and what's the loser? It's a mass of 1 kilogram times A. Now from that, we know that FT2 is 40 newtons. We don't know what FT1 is. We have 3 unknowns and 2 equations. Okay, let's go to the last one. Here. And that one, what's the winner? Oh my gosh, look at it out. If there's a driver's span, we'll all have to stay here. Come up into the science. We have Bunsen burners. We can cook things. FT1 equals the mass times A. So our 3 unknowns are Fe, FT1, and A. So how would you go about solving this? Well, Mr. Ring, we would do it the same way we always have been doing it. We would start with 2 equations and 2 unknowns. Here, we can solve for FT1 and A. And then, yeah, so FT1 actually equals 1 times A, doesn't it? From here, right? So we could just put that in right here. So we get 40 newtons minus, we're going to plug this in over there, 1 kilogram times A equals 1 kilogram times A. Add it to the other side, right? 40 newtons equals 2 kilograms A. So A equals 20 newtons over kilograms, which is the same as 20 meters per second squared. That's a fast freaking train once it gets going, huh? The third time around the track, it's going about 400 meters per second. So, all right. So our A is that. So if we bring that up to here, again, we can get FT1 is 1 kilogram times A, or 20 newtons. So we have that, and we have our A. And then now we can come over here and plug this stuff in. Fe minus 40 newtons equals 3 kilograms times A, but A is 20 meters per second squared. Fe minus 40 newtons equals 60 newtons. Add the 40, 100 newtons. So now we have it all. So you have to set up your free body diagrams, and then from those, everything should fall into place. Okay? Make sense? Can I move on? People are still writing. Huh? We're just waiting for Newman. Just kidding. Just take your time. Well, up to a point. Okay. What were you doing? You were just sitting there waiting for... It's equals. It's just this. It's winner minus loser. Number 2. A 55 kilogram girl should we make it somebody? Missy, we'll call it. We all know who Missy is. Is standing on a bathroom scale. In an elevator, as most people do. You could do it, though. If you have a big enough elevator, you'd be able to see it. The elevator has to adjust as it's moving, so you're really almost better with one of those ones that goes like that, because then when you start to move, you can see the change in it. The digital one has to respond to the change, and it might not respond enough. You might accelerate for such a short time you would only see it. However, like some people have the lab with the accelerometer that they take home, and they could use that riding up an elevator. So, are you laughing at my pronunciation of it? I have a hard time with that word, as I do with cylindrometer as well. Did you make a cylindrometer in Science Olympiad? It measures the salinity of water. I need help with one. Okay, she's standing on a bathroom scale in an elevator. At a particular moment, the scale reads 680 newtons. What is the acceleration of the girl at that moment? Okay. That's the first question. Okay, there she is. Now, what forces do we have in play here? Since we're talking about what the scale is reading, we're not going to use tension on the elevator. We're going to use F perpendicular up. Now, what is this girl's normal weight when she's standing still on Earth? 55 times 10, or 550, right? So she has 680 is bigger than 550. So we have her Fg down. So the sum of the forces, which is going to be up, by the way, equals m times a, and F perpendicular minus Fg equals the mass times the acceleration. But we know what the scale reads. It reads 680 newtons, doesn't it? That's what F perpendicular is. Minus what Fg is, which is 550 newtons, equals the mass of Missy, 55 kilograms, times the A, acceleration. 580 minus, or 680 minus 550 is 130. And 130 divided by 55 is 2.36 meters per second squared up. What does 2.36 meters per second squared up mean? Accelerating up, which could mean what? Will? Could be starting going up or slowing down going down. Yes. Because if you're starting going up, your acceleration is up, right? Because you're starting and then you're accelerating upwards. So increasing your speed going up would have an acceleration up. But if you're coming down and you slow down, then your acceleration to cause that slow down must also be against your motion, which also must be up. So both of those are times when the scale will read more than the person's weight. Okay. Okay. Your weight is always the same. No, wait. You mean what the scale's reading? The scale would read more, yes. As long as you're standing on it straight, right? If you're leaning on the side, it's not. If you're pressing down on the bar, it's not. Um, well, not really, because you have inertia that's moving you down. So your inertia is moving down, so even though you jump, I mean, there may be a split second, not even you're just pulling money out of, your parents just love that you go out and lose all their money all over the place, because you shove it in places. I found $10 in the hall the other day. No, I turned it into the front office. I don't want to be, they probably did, yeah. There's probably some collection that they got. End of the year party, which would be fine with me, but I could see it, like, pick it up off the ground and they look at a video camera or something. So, I don't want $10 in there. So, anyways, then at another later instant in time, the scale reads 450 newtons. What is Missy's acceleration? Hey, get back here. Okay. In this time around, FG is bigger. It's the same as it was before, but it's bigger than F perpendicular because FG would be, again, 550 newtons, and F perpendicular is only 450, so FG is bigger. The sum of the forces is mass times acceleration, and what's our winner in this situation? FG is minus F perpendicular equals MA, and FG is 550 newtons, just 55 kilograms times 10, minus what the scale is reading, which is 450 newtons, equals a mass of 55 kilograms times A. So that's 100 newtons over 55 kilograms equals A. 100 divided by 55 is 1.82. Which direction is that acceleration in? The direction of the net force, which would be that way, down. Will, what does a downward acceleration mean? Slowing down going up or speeding up going down, right? Yeah. Slowing down going up, speeding up going down. That's what the downward acceleration means. Well, let's think. Okay. The net force is downward, right? So there's a downward acceleration. If the acceleration's downward, you must be slowing down if you're going up, right? That make sense? And if the acceleration is downward, you must be speeding up if you're going down. Did that help at all? I don't know. All right. Study for the test. You can watch the rest of the video. I'm going to put E-block on here too and do some other problems, so watch the whole thing. That goes to all of you. Watch. I'm going to hit pause, and then when they come in, or C-block, sorry. I'll do C-blocks as well. I meant C! Anyways, okay. It would be the same video, but I'll hit pause, and when they come in, we'll pick up there, okay? Uh-oh. I'm missing part of the... I had more problems, though. I'll have to make ones up. Okay. That would assume I wrote the test yet. Okay. Numero trace. 120 kilogram go-kart does 2 laps around an 80 meter radius track in 2 minutes. What's the speed of the go-kart? What is its centripetal acceleration? What is the centripetal force needed to keep them on the circle? What type of force is acting on it? What is the minimum value of mu to keep them on the circle? Go. It's actually quite easy. What's the radius? So the problem says 120 kilogram go-kart does 2 laps around an 80-meter track. Meter radius track in 2 minutes. What is the speed of the go-kart? What is the speed? What is the centripetal acceleration? What is the centripetal force needed to keep the go-kart on the circle? What type of force is the centripetal force? And what is the minimum U? Stay on. Okay, so the go-kart goes around. And so if we were to draw the free body diagram, or let's draw it, you've got FG down and F perpendicular up, and then towards the center of the circle is FF. That's your, and that FF ends up being the centripetal force. Okay? So if you're driving home, going around the S curves, which if you took the S curves, it's just a portion of a circle, right? And you go around it at a constant speed, you're actually accelerating because you're doing what? Changing direction. So you're actually accelerating. And if that force that's keeping you, that's making you accelerate, is actually the friction of the tires that are keeping you going in the circle. And if you were to hit some snow that blew, then you could slide and end up in Forest Lawn because the friction that was holding you is no longer there, right? Or Hoyt Lake. So don't go so fast that that happens. Now, I should say you are a massive object in the car that's not bolted to the car. So as you go around a turn, you might feel yourself move. Your inertia keeps you moving towards the outside, right? So I took my son to the foot doctor yesterday, and we had to turn around like that, and I didn't wait for him to strap in nor shut the door. Now, he's only 11, so luckily he didn't fall out, but if he did, he would have been injured. So you always have to wait for the person your precious cargo to buckle up and close the door. Because his inertia would have kept him going in a straight line, right? If I started to turn with speed, he would have just moved in a straight line if he went out the car. Yeah, you see, so it's very dangerous. So, anyways, I was mad at myself. So this 120 kilogram cart does 2 laps on an 80 meter radius, so it's 80 meters. In 2 minutes. So 2 laps in 2 minutes. Oh, that's too easy for you, isn't it? 2 laps in 2 minutes. What's... No, the radius is. V is 2 pi r over t. What is your value for t here? Well, t would be 20 seconds? No. 2 minutes, 2 laps. So what is t? T is the time to go around once. So 1 minute or 60 seconds, right? I'll probably give you something like does 1.85 laps in 60.382 seconds. What's the period? Let's see if you can figure that out. 60 seconds, and R is 80, so we could get V, it's just 2 pi times 80 meters divided by 60 seconds. Two times 3.14 times 80 divided by 60. 8.37 meters per second. Once around, yes. Now, AC, notice how even though the forces that might cause centripetal motion are different, or could be a combination of forces, sometimes it's F tension minus Fg, like in a Ferris wheel, even though that's the case, the way you go about calculating Fc, which is your net force, is the same. You find V and you find AC. And AC is V squared over R. .9. That's my guess. .88. That's our AC. So we found here what is the centripetal acceleration. We found that. What is the speed? We got it. What is centripetal acceleration? What is centripetal force? Well, that's Fc equals m times AC, which would be 120 kilograms centripetal force times 0.88 meters per second squared. So mass times acceleration to get the force is 105.6 newtons. And as we can see from our free body diagram, the centripetal force here is all what? Friction. What's the mu value? Well, friction is mu times F perpendicular. So mu would be F friction, which is 105.6 newtons, over F perpendicular, which would be 1,200 newtons, because it's equal and opposite to Fg, or 0.088. All right. Well, if it keeps snowing, maybe you won't have your test tomorrow. They'll cancel. Number 4. Now, 1 through 3, I did earlier with the other class. But I'll come back. I got other problems, too. You can watch the earlier part. This is a test review. Yes, we will, I guess. Or at least there's one on here. What is all the ones you need? Okay, what is the force of gravity, like the ones that we use on our problems and stuff? The force of gravity between a 4 times 10 to the 6 kilogram boulder and a 200 kilogram grizzly bear. $50 meters apart. What is the force? Oh, wait. 50 meters apart is the first question. If 50 meters apart. What is the force of gravity between a 4 times 10 to the 6 kilogram boulder and 200 kilogram grizzly bear if 50 meters apart? Well, Fg is big G, m1 times m2 over r squared. That's a good formula to know. Big G is always the same. That's something that's in your reference table. Probably didn't have it memorized by now. The mass of the boulder times the mass of the bear divided by 50 meters squared. So sometimes the radius confuses things, but it's just like if you have the boulder and the bear and you swing the bear around, you see 50 meters apart, swing the bear around, makes a circle. That might be the case. Or at least mauled. Look at it out. It's so bad. Blizzard. You can't have school in this kind of weather. I know. The gravity. Good gracious, how many snow days do you need? Yeah, but how many do we possibly? We just had off. We haven't had a full week of school in like 3 months. Now, what if 150 meters apart? What's one easy way to do this? What did you do to the distance apart? What did you do to 3 divided? Okay, now you have to think it through, okay? So first say to yourself, with these distance problems, if you get farther apart, which we did, does it get bigger or smaller? It gets smaller. How much smaller? Well, how many times farther apart is it? 3 times, so 3 squared, 9 times smaller. Divide your number 2.1 times 10 to the 9, and you should get 2.3 times 10 to the minus 6 newtons. Yes. In this case, we could calculate it. to the minus 5. I divided this number by 9 because it's 3 times farther apart. 3 squared is 9. It's a ninth of what it used to be. Hold on for a second. Let me just see if it works, okay? First, the mass of the boulder is 4 times 10 to the 6. The grizzly bear is 200 kilograms. And now they're separated by 150 meters squared. So if you look at that in terms of before it was 50, right? Squared on the bottom. But now it's 150, which is the same as 3 times 50. 3 squared is 9. So it's got to be a ninth of what it was. Yes. I know, but because here's the boulder, here's the bear. Swing the bear around the boulder. You see? That's why we call it radius. Because it's anywhere that distance out in any direction. To the what? Three squared is 9. This was originally 50. 3 times 50. The 3 is also squared. Inverse square law. Oh, I didn't even touch it. See that? I know this is right. I don't know why I'm doing this, but... Yeah, it's my youngest. 2.37 times 10 to the minus 6. I'm glad you said that, actually. I'm just kidding. She's crazy. Yes. She's ridiculous, really, is what it is. Okay. Moving on. Oh, let's just do this. Okay, so if you're here, and you have an FG, okay? Now, if you take that and double the distance you are apart to there, what happens to your FG? So if this is D, and now this is 2D, well, what happened? Does it get bigger or smaller? Smaller. How much smaller? 4 times smaller, because it's an inverse squared law, so 4 times smaller. How about this? What if you doubled the distance and doubled the mass of one of them? Well, watch this. It's not that bad, because doubling the distance makes it a fourth of what it was, right? When the m, though, is not squared, it's m1 times m2, so we only doubled the mass of 1, right? So it would be a half of the original FG. Okay? Let's watch this one, okay? Let's we'll make half the mass of each, and the same distance. What would you do? It would be 1/4 of FG, because 1/2 times 1/2. What about, it might be, now that I haven't written it yet, so now that we're going over it, might be. Let's double the mass But double F, double the D. What happens there? Well, let's see. Doubling the D makes it what? Smaller or bigger? Smaller, 1/4. Double mass 1, double mass 2, it's still Fg. It's the same. Ooh. Yep. If you tripled it, yes, it would still be the same. What? Yes, yes, that's right. Okay, good. Here's another gravity problem, okay? What is this, 5? All right. A weather satellite is supposed to orbit the Earth 4 times a day. What is the proper radius for the orbit? Okay. Radius is meaning from the center of Earth. That would be a different question than altitude, because altitude you'd have to subtract off the radius of the Earth, right? Well, let's get the altitude too. We'll do both. So 4 times each day. So if you look at the equations, if you start with Fg is big G m1 times m2 over r squared, right? But if we look at when something's orbiting Earth, okay, when something's orbiting Earth, the thing that's keeping it in orbit is the centripetal force, so Fc equals Fg. And I did all this in the notes to come up with the formula, right? And the formula I believe we came up with was r cubed equals big G times mass of the planet times t squared, yes, divided by 4 pi squared, right? Okay? So that formula comes from the fact that V is 2 pi r over t, and that Fg is mg, right? So when you put all that together, you end up with this formula. Anyways, I don't want to do it again because of time, but you could have this formula on your formula sheet, right? So I would do that if I were you. So r is cubed would just be G times the mass of the planet. Earth is 6 times 10 to the 24th kilograms. What is, okay, the period we have to figure out. 4 times a day it goes around. 4 times a day. That's how many hours? And how many seconds are in each hour? Well, no. 3,600 seconds, not minutes. So 6 times 3,600. 21,600 seconds. Didn't we have that before? Don't forget to square it. Now the 4 isn't squared, only the pi is. Isn't that the case? Yeah. So 6.6, use this one. I get r cubed. You could try it on your calculator too. 4.73 times 10 to the 21 meters cubed. And then the cubed root of that is, see if you can figure out why. R would be 367, 1.68. This is like the same problem, isn't it? I didn't realize that we had on our homework. Right, so we have Earth, and right now we have this. Squared. Okay. Divided by, okay, now the radius of Earth is what? It's on your reference table. The radius of Earth is 6.4 times 10 to the 6 meters. So the altitude, what? You probably it's divided by 4. Only the pi is squared, not the 4. That's what I do. You're not getting the right answer? Okay, when you divide by 4 pi squared like that, you're dividing it by 4 and then multiplying it. So you have to put that in parentheses. That's like your brother saying. You know that? Your brother's saying that. Okay. So Okay, so when you do it like this, oh boy, break the desk. Too many hamburgers. I ate a veggie burger, by the way. Now, when you put in this, you're dividing by 4 and then multiplying the whole thing by pi squared. So you have to insert parentheses there. See, just, it doesn't have to be like that, really. You don't even need, it has to be that, see what you're doing is different. Whatever, that has to be in parentheses. The bottom has to be in parentheses. If not, you're going to divide it by 4 and then multiply it by square. There it is, right? And then cube root of that. Second. Now the altitude here would be 1.68 times 10 to the 7. That's right. This thing's driving me nuts. .04 times 10 to the 7 meters up, or about 10,400 kilometers. No, this is from the center of the Earth. This is, yeah, that's the altitude. Sure. A 1,000 meters, or maybe even 5,000 meters, but it's not going to matter much on this. It's driving me nuts. Duct tape to my head would be easier. All right, what was the one you wanted? Oh, an elevator. Let's do that real quick. All right, so this is on a 55 kilogram girl. Is standing on a bathroom scale. For fun, in an elevator. Well, if they wanted to measure it, they would. Yes. Scale reads 680 newtons. What is her acceleration? Well, if it's tension, it just means you take the whole mass of the elevator and the person. If that was the case. But here we're just talking about the girl. Darn it, darn it, darn it, darn it. Stop it. There we go. Okay? The forces on the girl are Fg down and F perpendicular up. right? Oh, actually, F perpendicular would be bigger, wouldn't it? Because FG, I know. How much is FG? 550, or 55 times 10, right? So F perpendicular would be 680 newtons. hmm No. In this case, it could be moving up, or it could be moving down. I mean, if the scale reads more, it means the net force is up, which means your acceleration is up. So if your acceleration is up, sorry, if the acceleration is up, right, then you're either increasing your speed up or you're decreasing your speed going down. So you're either, yes. So the sum of the forces is mass times acceleration, 680 newtons minus 550 newtons equals the mass, which is 55 kilograms, times A. So 130 newtons is 55 kilograms times A. A is 130 newtons over 55 kilograms, which would be 2.36 meters per second squared.